ACT is Thursday. Because the original plan was to have y'all take it today and y'all get a little bit of a break between it and the ACT. But unfortunately, it didn't fall out or work out that way. Now, with this test, 6-6 solving, I 100% believe y'all can do this in one class period. Y'all can do this in a whole class period. So again, we're going to finish going through this, but just be familiar with it for the most part. Because as long as you're not trying to learn it as you're doing the problems, most of them shouldn't take too much time. I believe there are 24 or so. It's all solving. There is one bit at the end of 8 problems I did add in. We'll go over them here that are very nice, very easy, just to kind of give you all some extra points at the end. So the next set we're going to look at is these here are inequalities. We want to solve these, and if we can't reduce them, we're going to leave them in exponential or logarithmic form. Number 17, the natural log of x minus 1 is greater than or equal to 9. So again, we try to get the log by itself first. Well, it is. Now we're going to put both sides to its base. And the base is e. E to the ln of x minus 1, those cancel out, giving us x minus 1, is greater than or equal to e to the 9th. If the base is e to a power, we leave it, because e is irrational. No matter how many times we multiply an irrational number by itself, it's still going to be irrational. It's not going to change it. Now we just need to solve for x. So we can add 1, telling us x is greater than or equal to e to the 9th plus 1. Questions on how we got to this point here? Now with our logarithms, we do have to be careful to make sure what's inside the parentheses is not negative or 0. And for us here, well, if we calculated that out, that would be our x minus 1 has to be greater than 0. So x would have to be greater than 1. Well, x is always going to be greater than e to the 9th plus 1, yes? Yeah. Is that value greater than 1? Yeah. We don't need it. And there's not a problem on the test that needs that restriction either. So you don't even have to worry about it. I made sure they didn't show up on the test, so you're not having to second guess or think about that. So x is greater than or equal to e to the 9th plus 1. That's our final answer. Questions on this here? Let's look at the next one. Log base 7 of x plus 2 is less than 4. Yes? We'd put both sides to the base as 7. We use 7 because the base of the logarithm is 7. So our 7 to the log base 7 cancels out, leaving us with x plus 2 is less than 7 to the 4th. If the base is a number, there's a good chance we can simplify it. 7 to the 4th is 2401. So we're saying x plus 2 is less than 2401. Yes, then we would indeed subtract 2. X is less than 2399. Questions on how we got to this here? All right. Now, this one here again, just like the previous one, what's inside the log cannot be 0. So we're saying x plus 2 has to be greater than 0. When I solve for x, I'm saying that x has to be greater than negative 2. And if we were going to include this or check this, we would say, is negative 2 less than 2,399? Well, yes. So for these here, we would have to add it. A negative 2 is less than x is less than 2,399. If they did show up, they're not going to on the test. we would add those. Now these specifically only apply to logarithms with inequalities. LOG. If we start with a log and it's an inequality, we do have to be careful for this restriction that we have to add back in. Bless you. Now, on the test, you're not going to have a logarithm that does this. It's all going to work out nicely. But, questions on 17 and 18. Number 19, 6 times the natural log of x plus 7 is less than 60. Well, is the logarithm by itself? No. So the first thing we have to do in solving is to get it by itself. So we'd subtract 7, telling us 6 times the natural log of x is less than 53. At which point we would divide both sides by 6, because we need the natural log by itself first. So we're saying ln of x is less than 53 over 6. Is the natural log by itself? Yes. So what do we do now? We put both sides to the base of e. E and ln cancel, telling us x is less than e to the 53 over 6. Questions on this here? We good with this here? Now on the test, this would be the answer, we'd be done. But again, we said that what's inside this logarithm cannot be negative or 0. So we're saying that this value of x has to be greater than 0, yes? Is 0 less than e to the 53 over 6? Yeah, so then we would have to add it in. Yeah. So the main places this comes up is if what's inside the logarithm would be 0 or negative. Does that make sense? And for the most part, if we've solved for x and found that x is greater than whatever that value is, most likely it's not going to even come up. Let's look at number 20. Is the logarithm by itself? Now we have 5 times that log, yes? So what do? Divide by 5, which tells us log base 7 of 4x is greater than or equal to 32. Questions on what we did there? What do we do next? Base of 7. 7, 7. Those will cancel, telling us 4x is greater than or equal to 7 to the 32nd. Is that a nice number? It technically, yes. Realistically, you would need a smarter calculator than what we have access to. So we're going to leave it at 7 to the 32nd. Because if we type this in either calculator, 7 to the 32nd, 1.104 times 10 to the 27th power. It's way too big. So this is one of the few times where we have a number as a base and we'll leave it. Divide by 4, telling us x is greater than or equal to 7 to the 32nd over 4. And that's it. Because it is greater than, if we did check for our restrictions or what x cannot be, it's saying that x has to be greater than 0. Well, that is indeed greater than 0 by a lot. Questions on this here? Let's look at 21. Is the logarithm by itself? No. So what do we do first? We'd add 5, telling us negative 4 log of x is greater than or equal to 8. Yes? Then we would divide by negative 4. That would give us log of x on the left side. A divided by -4 is -2. And we would flip our inequality sign. Because when we multiply or divide by a negative, we have to change the inequality sign. Because the step before that, the left side was negative, the right side was positive, yes? We divided. Now the left side is positive and the right side is negative. It flips. The signs flip, so we flip the inequality sign. Now we need to put both sides to the base what? 10. Because if it's not written, especially with log, it's understood to be 10. ln is e, because our 10 to the log of x just becomes x. Is less than or equal to 10 to the -2. Is 1 over 100 or 0.01. And for the most part, you really don't need the graphing calculator for any of this. The 30xs, the little yellow calculator, will do a lot of these here. 10 to the -2, 1 over 100, or 0.01. Now, again, what's inside the log has to be greater than 0, yes? Is 0 less than 1 over 100? Well, yeah, it's a positive number, yes? So we have to add it in. So incidentally, the range of values that work for this function are actually quite tiny. All the values that work for this are between 0 and 0.01. Yes, sir. Yes. Now again, adding those back in are not going to come into play on the test. I made sure that you're not having to add this back in. College algebra, they're going to make you especially have both. But for this one, I thought I'd be nice. Questions up to 21. You ready for 22? So we have 3. I'll rewrite it out. Since the x is in the exponent, we use logs. If it had been 3 times 3 to the 4x minus 5, then we would divide by 3. But for the most part, especially with 3, if the base of it is a number, like this one here, we're not going to have much with it. I don't know why, it's just not common to have a number like 3 times this here. The only time we really see that is with e. But here we're going to apply a log to both sides. Specifically, which log? 3. Because we want the base and the base of the log and the base of what we're starting with, 3, to match up. Because our 3, log base 3 of 3, pretty much simplifies out for all case and purposes, leaving us with the exponent, telling us it's greater than log base 3 of 108. I'm just curious. 108 divided by 3 by 3. Yep. So what I was doing there, because the only way log base 3 of 108 will simplify is if 108 can be rewritten as 3 to a power. So I was just dividing by 3 to see how many times 3 went into it. And it did go into it several times, but then we got a 4. So it doesn't work. It would just have to be all 3s. So leave it alone. Log base 3 of 8 is going to stay there. We're not going to simplify it. All it would be is a decimal. If you want to, or just make sure you can go math, log base, and do that. But for the most part, it's going to stay there. Now at this point, we need to solve for x. So we would add 5. Add 5 to both sides. The left side would indeed still be 4x. It is greater than log base 3 of 108, bless you, plus 5. Last thing we do is divide by 4. So x is greater than log base 3 of 108 plus 5 all over 4. And that's it. And that's as far as we're going to take it. Questions on 22? Now, since 22, the x started as an exponent, we don't have to look at restrictions because I can put positive, negative, rational, irrational. I can put anything I want as an exponent. Realistically, there are ways we can put I as an exponent. But we don't have restrictions in exponents. We do have them in logs. 23. I'm going to write it out again so I have a little more space. It is nice when we start with logs because we can put the base right up to the problem, starting problem, and just start solving. Here we might need a little more room. E is our term with the variable and the exponent, yes? So we divide it by itself, and we can apply the natural log. Now ln of e to the 3x plus 4 is 3x plus 4 is greater than the natural log of 11. The only numbers that simplify with the natural log nicely are e and 1. E and 1. Even though 1 appears twice, it's a different number. Now we just need to solve for x. We would subtract 4, telling us 3x is greater than the natural log of 11 minus 4. Telling us x is greater than the natural log of 11 minus 4 all over 3. Yeah. So our number to an exponent is already by itself, yes? So what do we apply to both sides? Log base 4 because our log base 4 of 4 to the x is x. Because unfortunately we cannot write 36 as 4 to a power. It feels like we should. It feels like we should be able to, but it unfortunately does not work. But that's it. Put that one there. Ah. There we go. Questions on 24? Okay, good. I thought it was going to 27. 25 through 28, I added these on. We technically covered them before the test, the last test, but I didn't put them on there. Now, you're not going to have evaluating. I removed that from the test. But this is going over our change of base. Log base b of m. We've had these time and time again, like on the last one, all of these here. We can do a change of base. And what that means, I can rewrite it as common logs, log base, or log of m over log of b. Now the question is, why does this make a difference? Well, in the 30xs, I could not type in log base 8 of 96 because it doesn't have that property. But with this change of base, I have now changed it to base 10. I can plug that into the yellow calculator. This is also the same as the natural log of m over the natural log of b. So for these last four here, you need to write it in common logs. Common logs, log, where the base is 10, or just log. Common log just means log. And natural logs, ln. So our log base 8 of 96, I'm going to write a fraction. Here, On top we'll have log, on bottom we'll have log. M is the number inside the log. 96. It will go on top. Our base is, and it goes on. So log base 8 of 96 is the same as log of 96 over log of 8. That's half your answer. Be ready for the other half. There it is. So we write it once with log, we write it a second time with ln. Because with these here, this change of base, we can put the base to be whatever we want. Normally we put it as base 10, so log, log. I could pick E. E is just ln. That is your full answer. That's why I threw these on at the end, because I felt that these should be nice, easy points to tack on to the end. Our next one. Log base 12 of 8. It'd be log of 8 over log of 12. Or we could say the natural log of 8 over the natural log of 12. That's it. That's why I put these on the test, to make it nice, have something that y'all can do real quick, get some few easy points to tack on at the end. Log base 100 of 2 would be log of 2 over of 100. Natural log of 2 over natural log of 100. Log base 1/8 of 9/7 would be log of 9/7 over 1/8. Or the natural log of 9/7 over the natural log of 1/8. Questions on these here? And that's everything. Do we feel good about this test? One.